Close your eyes for a second and imagine the sound. A single bag crackles open, a warm scent of potato and fried golden air rises, and that first bite, a satisfying, addictive crunch that seems to echo with a tiny celebration. That sound? It's the chorus of a factory humming with purpose. Welcome to the behind-the-scenes story of how Lay's chips go from humble tubers in a field to the familiar, crispy companions of movie nights, lunchboxes, and late-night cravings. This isn't a dry lecture. It's a sensory journey, a step-by-step backstage pass that puts you right on the factory floor, beside the machines, and people who turn raw potatoes into that perfect, thin, golden chip. Ready to discover the magic behind the crunch, and how engineering, food science, and human hands collaborate to make every bag of Lay's reliably tasty? What's the first thing you want to know about the journey from field to bag? From field to factory. Every great chip begins with a field. Potato sourcing is a precise art. Varieties are chosen for starch content, texture, and flavor, and because a consistent crop makes consistent chips. In big brand supply chains, agronomists collaborate with farmers month by month. Soil tests, irrigation plans, and harvest timing matter. Potatoes destined for chips are typically harvested at their peak maturity and quickly transported to the factory to preserve freshness. Delays introduce temperature variation and increased bruising, which affects yield and flavor. At the receiving dock, the story shifts from pastoral to industrial. Pallet trucks unload wooden crates or bulk bins, and the first checks are visual: color, size distribution, bruising, and signs of disease. Weigh stations log incoming tons. Traceability labels link each lot to its farm, harvest date, and any treatment history, a vital safety and quality measure. Sorting systems then segregate large from small tubers because uniformity makes the downstream process smoother. Slicers like consistency, fryers like predictability, and seasoners like even surfaces. Sustainability steps in here too. Many factories audit their growers for responsible water use, fertilizer management, and waste reduction. Partnerships might include crop rotation recommendations or incentives for harvesting practices that reduce soil compaction. Small upstream choices that ripple into better taste and lower environmental costs downstream. This step shows that snacks aren't magic. They're the product of careful choices that start long before the factory gates. Who knew that the first secret to great chips begins in the dirt? And which detail about the farm-to-factory handoff surprises you the most? The wash and sort ballet. Once the potatoes roll in, the factory starts a choreographed washing and sorting ballet. Conveyors carry tubers into high-pressure washers where jets of water, brushes, and gentle tumbling remove soil, stems, and stray debris. Machines are tuned to be firm where they must be and delicate where it matters. Bruised potatoes are fragile and need careful handling. Following the initial clean is a mechanical sorting sequence. Optical sorters and camera systems scan each tuber for blemishes, color irregularities, and form material. Those with too many eyes, green patches from sun exposure, or structural damage are diverted. Larger stones or foreign objects that accidentally entered shipments are separated out, protecting expensive downstream equipment and assuring safety. Water used in washing is often recycled after filtration and settling, part of modern plants' commitment to conserve resources. Pumps, sedimentation tanks, and filter media keep the process efficient while meeting sanitation standards. Workers perform manual checks too, trained staff stationed to catch what machines might miss, and to ensure that the tactile, human judgment complements technological precision. This stage is all about readiness: clean, uniform, and suitable for the high-speed choreography that follows. Have you ever thought about how many eyes and hands, human and mechanical, collaborate to make a single potato factory-ready? Peel and reveal. Peeling transforms rough, field-worn tubers into smooth canvases. There are a few different peeling technologies in use. Abrasive peelers that tumble tubers against rotating stones or rubber-coated drums, or blade peelers that slice away skin in a controlled manner. Many high-capacity plants favor abrasive systems for speed and efficiency. They gently remove skin while minimizing waste. The removed peel, actually a valuable byproduct, often goes to animal feed or composting operations, showcasing a circular approach to waste. Operators monitor peel depth closely. Too aggressive, and you lose edible flesh. Too light, and you leave skin bits behind that can darken during frying. Peeling lines include rinse stages to wash away loosened peels and any residual dirt. Worker stations along the line check for persistent blemishes and send compromised tubers to rework stations or discard streams. This is also where traceability data can be updated. Lot numbers move with the product down the line, and control points log temperature and exposure metrics. Clean in place, CIP. Systems are ready to clean the peeling machinery at scheduled intervals without dismantling the line, ensuring food safety by preventing microbial buildup. Peeling is deceptively simple to watch, but technically exacting in execution. What would you guess is harder to control in peeling? The pressure of the machines or the speed of the line? And why? Slice of perfection. Slicing is choreography in steel. Potatoes meet high-speed rotary slicers or wafer slicers that produce ultra-thin, ultra-consistent slices. The thickness and uniformity here define texture, frying time, and oil uptake. Modern slicers are calibrated to fractions of a millimeter. Even micro variations can mean a chip is too thick, chewy, or too thin, fragile. So engineers fine-tune blades, feed rates, and stabilizers constantly. Slicer lines often include washers or water sprays to carry away starch that's released during cutting. Too much starch on the surface will cause chips to clump during frying or develop an off-color. Too little affects mouthfeel. Slicer blades are made of high-grade stainless steel and polished frequently. Some plants run preheated or chilled slicing environments to reduce enzymatic browning and to maintain structure during cut. At this stage, metal detectors or magnets capture stray fragments from wear and tear, and an initial blanching or starch reduction step may follow to prepare slices for the next thermal process. Conveyor speed controls and slice bed depth are tuned so that slices lie evenly, exposing the right surface area to the fryer later on. The precision of slicing is where food engineering meets artistic judgment. The exact slice thickness helps define the chip's personality. If you could design your perfect chip, would you want it thicker and heartier, or whisper thin and ultra crisp? And why? Blanching, the secret pause. Blanching is the gentle, often overlooked pause that sets chips up for success. In industrial contexts, blanching usually involves briefly exposing potato slices to hot water or steam. This step removes surface starch, seals the surface to reduce oil uptake, and helps the final chips achieve an even, appealing color during frying. It's a controlled, short stay, long enough to leach excess sugars and starches, but not so long as to make slices limp. The temperature and time values are tuned to the variety of potato and the subsequent frying profile. Some operations use counterflow blanchers where fresh slices meet progressively cooler water, reducing waste heat and conserving energy. Other systems rely on steam blanching for better textural retention. The blanching water may also be treated and recycled. Blanching effluent often contains starch and requires settling systems or clarifiers to remove solids before reuse or disposal. This step is also a safety checkpoint. The process reduces certain microbes and prepares the product for hygienic handling. Operators sample the blanching batches for texture and color, while automated sensors monitor flow rates and temperatures. Blanching is a mix of science and patience, a quiet, critical interlude between raw and crisp. Does the idea of a secret pause in food processing change how you think about the time and care that go into your snack? The golden fry. This is the showstopper, frying. Chips move into a continuous fryer, a long, heated bath of refined oil, where slices travel on conveyor belts or mesh systems and transform into their signature golden state. Frying is more than hot oil, it's controlled chemistry. Manufacturers maintain oil at precise temperatures, usually between the right range for the potato type. ensuring Maillard reactions and crisp formation without burning. Continuous fryers are engineered for even heat distribution and fast throughput. Oil treatment systems filter out particulates and use continuous or intermittent centrifugal and filtration methods to keep oil clean and extend its usable life. Modern plants also monitor oil quality metrics like free fatty acids and polar compounds to determine replacement intervals, both for product quality and food safety. Oil uptake is a critical metric. Processors want enough oil to deliver flavor and mouthfeel, but not so much that chips become greasy or heavy. Technologies like de-oiling conveyors, centrifugal spin dryers, or vibratory conveyors can shed excess oil before slices move to seasoning. Temperature control, residence time in the fryer, and slice thickness all interplay to determine the crispness, color, and oiliness of the final chip. Frying is an orchestration of heat, time, and motion, a moment where chemistry is literally delicious. When you think of frying as a scientific art, does the next chip you eat feel more impressive? Seasoning symphony. Fresh from the fryer, hot chips enter the seasoning drum, a rotating tumbler where flavor is applied. The timing here is crucial. Chips are warm and slightly oily, the perfect state for seasoning to adhere. A combination of salt, powdered flavors, spice extracts, and anti-caking agents is prepared in precise batches. For iconic flavors like classic salted or more complex blends, formulators balance savory notes, acidity, umami enhancers, and natural extracts to achieve a reliable, craveable profile. Automated dispensers and weigh hoppers ensure accurate proportions, while vibratory feeders and spray systems add liquid flavor components when needed. Inside the tumbling drum, chips cascade in a slow, measured chaos, coating each surface evenly. Sensors monitor coating uniformity, and sometimes human inspectors perform tactile checks, feeling for even powder distribution or looking for clumps. Batch records trace flavor lots to seasoning components, and allergen controls keep production safe and compliant. For limited edition or experimental flavors, lines may be cleaned and validated between runs to prevent cross-contact. This is where the chips get personality. The seasoner is essentially a flavor conductor, making sure every note lands on every chip. Which flavor would you most like to watch being mixed and sprayed on a fresh, hot chips? Crisp check. Quality control. Quality control is the backstage team that ensures every bag meets standards. Visual inspections sample color and size distribution. Texture tests measure crunch and breakage rates. Moisture analysis verifies water content to ensure shelf stability. Labs run oil quality assays and microbiological tests where necessary. Sensory panels, trained tasters, sample batches for flavor fidelity, salt levels, and any off notes. Automated cameras and X-ray systems check for foreign objects, and metal detectors guard against metal contamination. For nutritional labs, proximate analysis gives fat, moisture, and carbohydrate profiles. Traceability systems log any deviations and initiate hold and investigate protocols if a metric falls outside limits. If an anomaly is found, the lot may be reworked, diverted to other uses, or discarded according to safety procedures. This is also the point where packaging specifications are verified. The right bag size, weight per bag via multi-head weighers, seam integrity, and nitrogen flush levels are all confirmed. The QC team is the product's advocate inside the factory, ensuring that every bag is safe, delicious, and consistent. Quality control is rigorous and relentless. It's the promise behind the brand. When you open a bag and it tastes right, how much do you credit the unseen team who tested it? Packing the crunch. Packaging transforms bulk chips into the familiar bag that travels to stores and homes. The line usually begins with a multi-head weigher, a precise machine that combines measured portions into an exact target weight. Weighers drop the measured chips into vertical form-fill seal, VFFS, machines that create the bag from a printed roll of film, fill it, and seal it within seconds. Before sealing, many manufacturers employ a modified atmosphere packaging, MAP, process Nitrogen is flushed into the bag to displace oxygen and preserve crispness and flavor while reducing oxidation. Seam quality is critical. Hermetic seals protect against moisture and staleness. The film itself is chosen for barrier properties and print quality. It tells the story to consumers and protects the product on shelf. After bagging, bags move to case packers that group bags into cartons, then to palletizers and stretch wrap stations for secure transport. Automation, sensors, and vision systems check that each bag is printed correctly, filled to weight, sealed, and that coding, used by dates, lot codes, is legible. Reject stations remove underweight or misprinted bags, and operators resolve issues quickly to maintain lineup time. The packaging step is the choreography that converts food into a product you can hold in your hand. After seeing the technical care here, does your next snack feel more like an engineered product or a simple pleasure, or both? Logistics and shelf life. From the packing line, the journey continues into warehouses and logistics networks. Bags are palletized and moved to climate-controlled storage. Not too hot, not too humid, conditions that preserve texture and prevent flavor degradation. Inventory systems rotate stock using FIFO, first in, first out, practices to ensure older lots are shipped first. Distribution is a carefully timed ballet. Retail orders, freight planning, and route optimization software ensure that shelves are replenished at the right pace. Larger brands coordinate with retailers on promotions and demand spikes, and cold chain considerations may be applied for some specialty products. Transit packaging protects bags from crushing and moisture, and route managers plan for temperature extremes in summer or winter that could affect product quality. Shelf life is defined by stability studies. Manufacturers test how long chips retain acceptable texture, flavor, and safety under various conditions. Packaging selection, oil oxidation, moisture migration, and storage conditions all determine the printed best before date. This technical science behind a simple date on the bag ensures you get a crunch that's consistent and safe. When you see a best before date, do you imagine a lab where people tested these exact conditions? And does that surprise or reassure you? Beyond the bag, sustainability and innovation. Factories don't stop at making great chips. Many are innovating to reduce waste, save energy, and push packaging forward. Oil recovery systems reclaim and treat used oil. Peel and chip trimmings are routed to animal feed or bioenergy systems. Water is filtered and reused. Energy efficiency programs, heat recovery from fryers, LED lighting, and variable speed drives trim the facility's footprint. Packaging R&D explores reduced film approaches, recyclable materials, and lighter films without compromising barrier performance. On the product side, formulation teams experiment with lower sodium blends, alternative oils, or new flavors inspired by global cuisines. Pilot lines test small batch runs before scaling to full production, letting engineers and chefs collaborate to keep innovation fast but controlled. The human side matters too. Training programs, safety initiatives, and community engagement tie factories to the places they operate. Visiting a plant often reveals a prideful team dedicated to craftsmanship at scale. The future of chips blends craft, science, and responsibility. After seeing how far-reaching the factory's decisions are, what would you change or keep if you ran the plant for a day? The final crunch and call to action. We've walked the full track, from seed, soil, and farmer care through washing, peeling, slicing, blanching, frying, seasoning, strict quality gates, packaging, logistics, and a forward-looking commitment to sustainability. Each stage balances speed with control, scale with attention, and automation with human judgment. The result is not just a snack, but a carefully orchestrated product of engineers, food scientists, operators, and farmers working together to produce a reliable, delicious experience. If this script is for a video, imagine it ending with a slow-motion shot of a single chip falling into a bowl, the crunch sound exaggerated, and the narrator asking the audience to taste mindfully next time. If it's for a live presentation, picture a final Q&A where audience members guess how many potatoes an average factory uses per minute, a playful way to underscore scale. Now it's your turn. If you were to create a short video from this script, which scene would you open with? The farmer in the field, the whirling slicer, or the moment seasoning hits the fresh chip? And why? Strong CTA. Love this behind-the-scenes tour? Bring it to life. Grab a camera or your phone, pick one chapter, and make a short clip showing that moment. Then share it with your audience or class. If you want, I'll help you adapt any chapter into a ready-to-shoot scene-by-scene script, including shot list, narrator lines, and on-screen text. Ready to turn the factory floor into your next viral lesson. Which chapter should we film first?